In this question, there are two slits S1 and S2 placed symmetrically around the central line, illuminated by monochromatic light of wavelength lambda. S1, S2 separation is D. The light transmitted by the slits falls on a screen S0. This is screen S0. The distance between the slits to the screen, perpendicular distance, is capital D. There is another slit S3 on the screen, and the screen is cut into form a slit that is at the center of the screen, EQ distance from S1 and S2 along the center line, perpendicular bisector. There is another slit on the screen S0, which is at a distance Z above the central line. Another screen SC is placed further distance D away from S0. Based on the above facts, find path difference to S4 if the Z value is d lambda by 2. So the first part is, what is the path difference to this particular point if the Z value is d lambda by 2. S1 to S4 is one path. S2 to S4 is the second path. We have a direct formula. So if you don't remember the direct formula, you can take this as a right triangle. S2, S4 is a hypotenuse. So base square is d square plus altitude square. Till here is Z. This is half distance d by 2. So Z plus d by 2. So S2, S4 square is d square plus Z plus d by 2 the whole square. The main derivation we have done, we have taken that as yn plus d by 2 whole square. Here yn is Z, d square plus Z plus d by 2 whole square. Same way, S1, S4, when you find, you can take this as a right triangle here again. So hypotenuse is S1, S4. Base is again capital D. The altitude will be Z minus d by 2. Like yn minus d by 2, we have done in the normal derivation. So S1, S4 square will be equal to d square plus Z minus d by 2 the whole square. So finding the difference of S2, S4 square minus S1, S4 square, d square get cancelled. So d square will go, then this a plus b whole square minus a minus b whole square, which can be 4ab. So d square will go, a plus b whole square minus a minus b whole square is 4ab, 4z into d by 2. Here you can split a square minus b square is a plus b into a minus b. S2, S4 minus S1, S4 into S2, S4 plus S1, S4 equal to 4 into z into d by 2. 4 and 2 will go, 2 will come. Take this to the right side, S2, S4 plus S1, S4. For small distances, we have approximated S2, S4 and S1, S4 both are capital D. This will become 2D. This will be the path difference. So S2, S4 minus S1, S4 equal to 2ZD by this S2, S4 plus S1, S4. For small values, normally it is small, will be 2D. So 2 will go S2, S4 minus S1, S4 equal to ZD by capital D, which is the path difference. Now, the first part of the question, we can give the value of Z. If you remember this derivation, you are not supposed to do this whole step. This is a main subsection of the derivation for the path difference. Then the bandwidth for Young's double slit. Now just substitute Z here. If Z is d lambda by 2d, path difference is d by d into Z, d by d into d lambda by 2d. So d and d get cancelled, lambda by 2. So that's answer for the first part. Now second part, they're asking ratio of maximum to minimum intensity observed on SC if Z is d lambda by d. So the condition is changed. Now for finding the maximum intensity of second screen SC, these two act as the coherent sources, S4 and S3. So first we need to find what's the resultant intensity at S4 because of these two. Then we have to find the resultant intensity at S3 because of S1 and S2. Those two act as the intensities for the screen SC. So if Z is d lambda by d, the path difference to S4 will be d by d into d lambda by d. The dd gets cancelled, lambda. So the path difference to S4, if Z is d lambda by d is lambda, we can find the phase difference. Phase difference will be 2 pi by lambda into delta. Lambda, lambda get cut, will be 2 pi. So the phase difference to point S4 from S1 and S2 is 2 pi. Now we can find the intensity as S4. The intensity at S4, we can call it as I4. Since both are identical, 4I1 cos square phi by 2. Phi is 2 pi. 2 pi by 2 pi. Cos pi is cos 0 is 1. Cos pi is minus 1. Square will be 1. So it will be 4I1. So we got the intensity of S4. Now if we get the intensity of S3, we can treat that as I1 and I2 for the second screen. Since S1 and S2 are equally spaced, the path difference will be 0. Path difference 0 means again cos 0 will be 1. So the intensity can be 4I1 cos square 0. Cos 0 is 1, 4I1. So both S4 intensity and S3 intensity are 4I1. So S4 intensity is called I4. S3 intensity is called I3, which act as the coherent source intensities for the next screen. Now for the maximum intensity on the screen, we already have a formula, root I1 plus root I2 the whole square for maximum. Minimum intensity will be root I1 minus root I2 the whole square. Here I1 and I2 become I3 and I4. So maximum intensity on screen SC will be, what are the source intensities, which is I4 and I3. So root I3 plus root I4 the whole square. Both are 4I1. 4 comes out as root 2. So 2 root I1 plus 2 root I1 the whole square. 4 root I1 squaring 16 I1. For minimum intensity, it is subtract and square the intensities. So root I3 minus root I4 the whole square. Since root I3 and root I4 both are 4I1, that will be 0. Now the ratio between the maximum to the minimum. That is 16I1 by 0 or 1 by 0 is infinity. That's a final answer.